Hello everyone, welcome to this video tutorial on Newton-Raphson method to find out the roots of the functions in MATLAB. These are the learning outcomes of this video. After this video lecture, you will be able to understand the working of Newton-Raphson method to find out the roots of the function. Then you will be able to create user-defined function in MATLAB for Newton-Raphson method. So what is the root of the function? For function f of x, let's say this is the function f of x. The root of the function is the value of x at which f of x becomes 0. So this is the value of x at which this function f of x will become 0. So this is nothing but the root of the f of x. Or in mathematics we can say that the value of x at which satisfies the function. So in Newton-Raphson method, it is a numerical techniques to find out the approximate root of a real value functions. So here we find out the approximate values of the root of the functions. So it works on the approximation of the curve methodology. Okay, let's suppose this is the function f of x denoted by this line, green line here. Now what we do, we initially assume x0 as initial guess or initial root of the function f of x. Okay, now how we can say that x0 is a root of the function? If it satisfies the function, or it f of x0 will be 0. Now here if you substitute x0 in function f of x, the value f of x is not 0. So this f of x0 is not a, or x0 is not a root of the function. Now what we do hereafter, we plot or we approximate the function f of x. So to approximate the function f of x or this function, we draw a tangent line here like this. So this tangent is nothing but the approximation of function shown in here using the green curve. So next thing is what we have to do, we have to find out this x-intercept of this tangent. So this, to find out this x-intercept, there's a we will use the slope of the line. Now to find out the slope of the line, we can use this function f dash of x, that is slope, f dash of x0, that is slope, which is equal to y2 minus y1 divided by x2 minus x1 for this tangent line. So these are the coordinates of point 2 and these are the coordinates of point 1. Now remember that we have to find this x1 value, and we will use the slope of the line of this tangent line to find out the x1, that is intercept, because this x1 is the better approximation of a root than x0. So we will use this slope of tangent line. Okay, so f dash of x0 means the slope of this tangent line, which is equal to y2 minus y1, which is equal to f of x0, this value, minus 0. So this is y2 minus y1 divided by x0 minus x1. So x2 here is the x coordinate of the point 2. We will consider this as a point 1 and this as a point 2. So this will become x0 minus x1. Now if we shuffle this mathematical expression, this denominator term will go here, and this f dash of x will become the denominator here. So x0 minus x1 will become will be equal to f of x0 by f dash of x0. Now from this we will get the x1 is equal to x0 minus f of x0 divided by f dash of x0. So this is the formula derived by Newton and Raphson to find out the next approximation of the root. Now if we generalize this formula, we will get that the next approximation is equal to the current approximation minus value of function f xn divided by f dash of xn. Now what we do generally, so at current x1 is the approximation. Now if we substitute x1 into function f of x, we'll get f of x1. If this value f of x1 is 0, then we'll call x1 as the root of the f of x. But here it is also not equal to 0, so we'll again draw a tangent here and we'll calculate x2 using this formula. So x2 will be equal to x1 minus f of x1 divided by f dash of x1. Now we will substitute x2 into the f of x, and if f of x2 is 0, x2 will be root of equation. But also here also x2 is not the root of the equation. Then we'll plot the tangent here and we'll calculate the x3. Now x3 will be equal to x2 minus f of x2 divided by f dash of x2. Now this, if we substitute this x3, we'll get f of x3 approximately equal to 0, and thus we will consider x3 as a root of the f of x. Now if we will calculate x4, that will become x3, because f of x is going to be, f of x3 is going to be 0, so x4 will be x3. Now here we have to stop, because the value of the root, there is no much more change in the value of the root what we are getting, so we have to stop iterating here. Now we'll go to the MATLAB and write a user defined function for this Newton-Raphson method to find out the root of the equations. So to write the function, we'll start with a new live function. So brief summary, this is Newton-Raphson method. And I'll make this as a title, and just for simplicity I'll write this function here. So this is the function we have to use. Okay, now we will modify this function definition. We want a root of the equation. The name of the function will be root underscore NRM, that is Newton-Raphson method, and the input will be f value, which is nothing but the function for which we have to calculate the root, and x0, that is initial guess. So I will write what is f and x here. So f is the function for which root will be calculated. Okay, then x0 is the initial approximation. Okay, so we will consider this f as a function of x, f of x. Okay, so to consider this as a function of x, we have to declare the symbolic variable x. So declare the symbolic variable. To declare the symbolic variable, we use the term SYMS, sims and x. So this is going to be our symbolic variable because our function will be written in the form of function of x. Next thing is that we will calculate this f dash of x. So next is calculate the differentiation derivative. I will write derivative of the f of x. So I'll write it as a dy. Okay, dy is nothing but differentiation of f with respect to x. So that's it. This is going to be a differentiation with respect to x. Now what I will do, I will save this function. I will save this function. So we'll go to home, live editor and save. Now make sure that you are saving this with the same name as a function name. So root underscore nim. Okay, I'll save this thing. Okay, then and initially what we'll do, we'll try to figure out what is the function, how it looks like. So we'll plot this thing using fplot. You can also use ezplot or fplot, works the same, and we have to plot this f function f. Okay, I want grid on. So what we'll do, we'll run this once again. Once we'll call syms x and we'll call this function the f will be, I'll write x square minus 4 and initial guess will write 5. Okay, and we'll enter. So this, sorry, I have to write this 5. So we are getting the function plot here. Now I want grid on, I have kept a grid on. I'll also plot x is equal to, y is equal to 0 line here. So the horizontal line, to plot that thing we have to use plot fplot. Now we want a horizontal line or x-axis line, so y is equal to 0 we have to plot. Now we'll once again save this thing, and we will plot this function. Oh, so we have to use hold on to plot the two plots or two figures on in the same axis. Now I'll close both the figures here and I'll call this function once again. So you can see here we have x-axis, that is y is equal to 0 line, along with the plot of this function. Now we'll move forward. Now what we have to do, we have to do a iterative procedure. So to perform the iterative procedure, we have to perform the iterative procedure. Okay, to perform the iterative procedure, we can use for loop or while loop. Okay, so to perform the iterative procedures, we can use for loop or a while loop. For a for loop, we must know the number of iteration in advance. To use the for loop, right? To use the for loop, we must know the number of iterations in advance. But here we don't know in how much iteration we will find out the root, approximate root. So here we don't know the number of iterations in advance. Thus, we will use the while loop. Now, what is the syntax of while loop? While, you have to write a condition here and you have to end. Okay, so this condition we have to write. So this is the syntax. Then there will be a body of the loop. Okay, so this is the syntax for a while loop. Now if this condition is true, this will run. If this is true, condition is true, loop body will be executed. So if this condition is true, loop body will be executed. Okay, now what will be the condition? What will be the condition? I will move to the slides. So condition here is that the x4 or xn plus 1 minus xn will become 0. At that point we have to stop. So we go to next point. For condition is xn plus 1 will be equal to xn, that is xn plus 1 minus xn will become 0. We have to use this condition. So I'll write check here. Check is equal to 1. Now if check is, I'll write condition here, check is greater than 1 e to the power minus 3. If it is greater than 1 e to the power minus 3, we have to check, and check here is nothing but we calculate check. In each iteration, check will be xn underscore 1 minus xn, that will be the check. Okay, so we will calculate xn underscore 1 minus xn. So what will be the value of xn underscore 1? 1. It is nothing but xn minus will go to the formula xn minus f of xn divided by f dash of xn. So what is f of xn? You have to substitute in f in place of x value of xn. Okay, now say similarly we have to divide it and we have to substitute in dy, that is in differentiation, in place of x xn. So this will become xn plus 1, that is xn minus substitute xn. Now for simplicity we will write VPA, so this will give us a numerical results. We will write VPA, so this will give us a numerical result. It will not give us a symbolic results. Okay, it will give us a numerical values. Now we want this numerical values to the rounded off to the 4 precision. So we'll use the round function up to 3 precision points. I want the values, so we can get the xn under n xn plus 1 value here. Okay, now what we will do, as we know that this is the initial guess. We have, let's say, x is equal to 5 is the initial guess. We will plot the value here f of, we also plot the value f of x0. So f of x0, so to plot that thing, as we have folded on the graph, you can directly plot. The x values will be xn and xn. Okay, xn and xn, as we have to plot the vertical line starting from x0 and ending at x0. The y values will change. Y value will be initially 0 and at the end this will be the value of y. So this will draw a vertical line starting from xn comma 0 to xn comma this f of xn. Okay, now we also want the numerical values here, that too rounded up to the 3 precision points. So round this up to 3 precision points. Now what we do, draw a vertical line from xn comma 0 to xn comma f of xn. Okay, so this will draw a vertical line from xn comma this. Okay, now what else we can do? Now we have done the check. Yes, we just have to continue the loop. So to continue the loop, we have to replace the value of xn. For the next iteration, xn will become xn underscore 1, and after completing the loop, stopping the loop, we'll get the root is equal to xn. Okay, so value of xn will be the root, or x underscore 1 also will be the root, doesn't matter. So here it ends. We'll save this function and we'll try to run this thing for the same. Now we don't know xn. Okay, xn, what we have x0 values. So what I will do, I will change this only to xn, and where I have used 0, so no, I'll save this thing and I'll run. So we got the root 2.9. What was our equation? X square minus 4, it should be 2, and we're not getting the exact value. Check is greater than, check is equal to xn minus, this should be xn minus xn underscore 1, because xn is greater than xn minus 1. Yeah, so we got the value 2. Now we will increase this figure. Now you can see here, this is the first. For x is equal to 5, we got y is equal to 21. Then for x, the next approximation was this value, x is equal to 2.9, and for 2.9 we got this value 4.41. Now again there is one more approximation. You can see here, this is the iteration number 3. We have x3 2 point something 14, and we have x4 here 2.005. okay, and it stopped here. So actual value is 2, but we got the value 2.005. so as we have rounded off the values, we got this root. Now we'll check with the another function. Let's say x minus 4, and the value will give the initial condition as, or initial guess as a -1. We'll check what will happen. So x is x minus 4, function was x minus 4, so value should be 4, and we got the root is equal to 4. okay, so this is how it worked. Started here only, and directly we got the root, because if you plot a tangent here, it will directly go to the 4 only. So this is how it works. Now we can check more complicated functions. Sin of x plus x square. I'll try this. We got a minus 0.891. Now we can check here. Here we have a root. This value -87, -89, more closer to this. We go more closer to this. Value is -0.87, and we got -0.89. Now if you want the more correct value, you can increase this to -5, and if you run this thing, will go more closer to the roots, but it will run this value for more number of iterations. I'll change this initial guess to 0, and we'll check with the 0. So if you give this initial guess 0, is going to give the incorrect results. So that is the drawback of this method. I'll write 2 here, and then we'll check. Getting answer is 0. You can see here it has plotted the lines. Yeah, it's near to the 0. On positive side it is 0 0. That was not incorrect answer, it is the correct answer. 0 is also the root of this equation, because we'll see if you put x is equal to 0, that is a trivial solution. What is our equation? Sine 0 will become 0 and this will become 0, so 0 is the trivial solution. And if you want non-trivial solution, you have to give this minus 2, so it will find out the root, minus 1.3. Now as this is the approximation, we are not getting the exact values for the complicated functions. Yes. Actual value should come near about 0.87, minus 0.87, and we are getting this. Yes, here we are getting this 0.88. So the value is in between 0.87 and 8 and 0.876 minus. So that's it in the Newton-Raphson method. So we'll check it on another equation. Polynomial x cube plus 2 star x raised to minus 2 plus 3 and x to the power minus 2 and 3 with the initial value of 10. So you can see here, this is how the plot of this function goes to infinity at x is equal to 0. But this thing here, it is like this. So we started with the minus initial guess as a 10, and yes, went to the 1.593. But this is also an incorrect answer, because this function is going to the infinity at x is equal to 0 according to this function. So if we provide minus 10 as initial guess, so we'll get minus 6 here. Check is yes, I'll correct that. Absolute value of check should be, now we will get all the values correct. Here, yes, minus 1.563 is the correct answer here. This was also the correct answer then, minus 1.563. Yes, here we got the answer. So that was the flaw here. Now you can get correct answer for each and every function. Here also you will get 0.877. Yes, we got this value 0.877. You can cross check with any function now. Values 2. Okay, so thank you for watching this tutorial. Please like, share and subscribe to the channel, and thank you once again.